have it. Python 1a pi. So again, what I'm not so sure about is what is the difference between these and like higher dimensions other than I guess these expression here. Like this is so close, man. This is so close to the actual answer. Look at these. I mean, what is the, just I want to make sure. So you have another expression that is basically, you know, so what do we have? We have, so we have something to the rational 3, 2, and this something is a 3 divided by pi. Is that correct? Yes. And so what if I say p print expression minus s5 oh yeah, okay. S5. Well, I guess I'll just do a rational, and this is 3, 2, and then it's divided square root of pi. This does not get simplified or anything. Let's simplify. Like this is not equal, right? I'm just not being stupid and missing some inequality here. No, okay. All good. Well, can I just print can I assert or check if something's equal? It doesn't matter. Anyway, so all good. But what is the problem then? So I'm doing it on R, 0 to infinity, then 0 to pi. Why am I doing 0 to pi? What if I do these? Like I'm just literally doing trial and error now. But let's see. No, interesting. No, it's 0. Really? So what if I do so let's so S2, S3, let's print some separators. That's awful, actually. What is the line break? Is it like this? So this is S2. S3. S4. And S5. S2 is awful. S3. S4. So S2 is okay, yeah, because we're getting rid of the e's because of we have 0 and infinite. Yeah. It's alpha. Because here's like the whole thing to Hmm. Can I just do this to add an empty line everywhere? Yeah, but that's quite loop. Anyway. And S4 adds the pi in here. How does this work though? I'm not so sure. Yeah, it's fine. That's more like about the specifics of the integral, but it's fine. Not polar, but like cylindrical coordinates. Cylindrical coordinates. Why is it that here they do this thing where it's like a change of variables, but they keep these things like that. Wiki how? No way. Here they just do r dr d theta dz. And here is like wait, why this seem to be two definitions? I don't understand that. I totally don't understand that. This is what I found was different. Like why do I have the sinus here? I think it was just so what if I do What if I do just R? Just do R, and then is dz, dr and d theta. Should probably just kind of comment all these, and then there's another option which is basically, what did I say, dz. So first is like, we have b and c, so we'll use b. And the theta. Okay, so for we use b, no, c. So we'll say c between 0 and 1, because I think this was where the z, like, then we do r between 0 and infinite, and then we do beta between 0 and 2 pi. Correct? It is just times r. Let's see. It's a bit different in this case. Yeah? It's not exactly that. Because it's square root of 2 times a, that's definitely not. Where did I get, what's the difference between these and where did I get that? Cylindrical coordinates and polar coordinates. So maybe that's a difference. That's double integrals in polar coordinates. Yeah, but that's double. R sine. In spherical, oh, in spherical coordinates. That is the difference. Interesting. Okay. Ah. Cylindrical coordinates. Why? Why? Ah, okay. Still, that should work. Can you do quadruple integral in polar form? For the integral? Yay, integrate n-dimensional spherical coordinates. I think I checked that already. Yeah. Oh, there's a general form. Look at these. Oh my god. Look at these. So I think this is what it's telling me is the pattern is like r to the power of n minus 1 times the sine to the power of n minus 2 minus 3, and so you kind of go down. So what if I would just go and do that? Let's check it out. I'm so desperate that I'm like not even trying to think why I'm doing it. So I think it's like a 3, and then this is like square. I think that's what you do. Oh, there's another angle. Yeah. And so now you do and I just this seems too this seems too complicated for the first exercise in this fucking book. I'll call this C2. And so we're gonna have another symbol. Called C2. And so C2. So this is R to the third times sinus to the second times sinus C2. And then we are gonna basically have another step. First you do C and then you do C2. Same thing, but this is like 3.1 3 1 3 1, and this is S3 and this is S3 1. Something tells me that's not gonna work. No. Maybe 2 pi. 3 pi. It's different. It doesn't seem like it's. Oh. Why? I don't know. Yeah. Nah. 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 No, no, no. But it's something. Something along these directions. I mean, I think we got this one almost right. Also not fully right, but I do 2 pi like why wouldn't that? why is that 0 though? If I so S2 is these, and then S3 it's just that actually says 0. If I take this, is it gonna result into something useful, or is it gonna break because I'm getting multiple results probably? Yeah. Because I'm trying to do 3-dimensional coordinates here, assuming it's just two-dimensional plus, you know, it's just yeah, that it's a 3-dimensional function, or it's a 2-dimensional space. That's what I'm assuming here. It just feels too complicated. It really feels too complicated. So what's the difference between cylindrical coordinates and spherical coordinates? Okay, in cylindrical coordinates you just specify an angle, which is maybe what would make sense in this case. An angle, an R, and a Z. Right? Triple into triple goes in cylindrical coordinates. And so here is basically, you know, because we know Z, right? So Z is going to be what shape, what fucking shape is this gonna have? That's what I'm maybe interpreting wrong still, right? Because it does kind of, you know, do like these when you think about it, like R, but that's just to tell you the values, right? Like if I think about the 2D, the 3D space, and then you have yeah, actually Z goes to infinite as well. Maybe that's the thing, right? So let's imagine this is Y and this is X, and so any point here, you know, it's got these coordinates, but then this is the radius, right? So and this radius is going to be you know, then you're going to have the value of, like, let's say, you know, if this is like that. That's how this grows. So this is, you know, 0 and and infinite, and this is kind of radius, right? So for these radius here, they're all gonna have these value, like ZR, right? So it's gonna have ZR, and then all the elements that have the same radius are gonna have the same ZR, right? But actually, these ZR can be infinite. No, it can be at most 1. It can be at most 1 because that's how you're gonna get, like, you cannot get higher values here. No, well, you cannot get higher values. What was this Desmos again thing? Desmos plot. So it was, let's say 3 whatever to the exponential, and then it was like minus, you know, 2 times x, something like that, right? Was it? Was it like this? Yeah. I mean, okay, so these number here, like these actually can be whatever, right? So, oh, look at these. That is going to be n. Ah, interesting. That's an interesting observation. That's going to be n. N is like, yes, because when the radius is 0, right? Okay, so this could be n. Okay, that's not bad. What if alpha is, are we assuming alpha is positive? That's the first thing that we're doing. Are we assuming alpha is positive? No, we're saying it's non-zero. Alpha could be also negative, and therefore making these like, you know, 6, and then it's kind of the other way around. And so the z would still be the maximum value, you know, because you'd say radius 2, and then it will basically, with radius, if you put in the 2 here, it would basically give you these. Okay, no, then it's like super high. Like they're insanely. I'm gonna, you know what, I'm going to assume that it's positive. I think it's sensitive to assume it's positive because that's why you have a minus there, right? It's sort of, I think you can assume it's positive. Let's assume it's positive. Then the z is always capped at that because this would require negative radiuses, and that's not what we want. You know, we can't get that. So actually, the max that you can get is n. Like, you know, z max is going to be n. So yeah, in theory, I mean, you can do, yeah, you can, then we can do it like we can do it with cylindrical coordinates, which is you need the angle. So what's the cylindrical coordinates thing here is r dz dr d theta. So we're gonna do just r r, right? And then let's just use b here, right? So r. So first we do z. So for z we're going to use the c, and it's 0 until n, right? First we do z, then we do r, and so r is going to be 0 to infinite, and then we do theta, and theta is between 0 and 2 pi. This is theta. Huh? Maybe we can just call this z then. Just call this z. See if that works. I think it does. Almost. No. Kind of. Wait. I think it does. Fuck. Isn't that the same? No, wait, what? No, but it's really similar. What? No. Can I simplify? So this is, again, it's 2/3, this is 2/3, but then it's like there's not really that's not our answer exactly. It's, sorry, 3 divided by 2. Oh, that's 2/3. That's bad. That's 2/3 as well. It's not. No, it's not. No. Nah. Well, because I'm doing something wrong here. I'm taking a look at the function, and I should take a look at the square of it. You know, I should take a look at the square of it. But okay, it's just n squared. This is what you're getting here. Yeah. Okay, that's the only difference. But I don't think that's going to change anything. No, but it's somewhere in this direction. It's somewhere in this direction, R. Oh wait, no, it's not R. Oh, sorry. No, what? R dz dr d theta. Dz Yeah. dz dr d theta. It's almost there, but my function is this one. It's the complex conjugate. We're assuming it's real. If I don't assume that, then it's messed up. Oh man, we first do with a really first with a z. And then R and then theta. This should be the right thing. That definitely should be the right thing. Says the function times R. Sure, that's correct. And then we do z, and z is, so we integrate across z, and z is between 0 and n. And then R. Maybe there's something wrong here with R, but R can really be infinite, right? R can be definitely infinite, can it? Yes, it can be infinite. It's a radius. And again, let's take out the pain. Like R can just be whatever point here. It's just gonna have something else. So it's gonna be, there's this symmetry around, you know, the z-axis. Oh, and it's cool. I've learned some new stuff, but it's still 0 and infinite. S2, and then S3 is basically theta, and it's between 0 and 2 pi. I don't know. Let's give it another try next time. We're getting closer.